This video, we are going to extend our knowledge on vectors, talking about standard unit vectors. Okay, so a standard unit vector is a unit vector, so a length of 1. The reason they're called standard unit vectors is because they represent a change in x, change in y, and we'll actually have a third part too. So let me go ahead and graph these to kind of show you what they look like so we understand them. This is our vector I, typically written like this, I hat, because it is a unit vector. That vector, if I put it in standard position, right, goes from here over to 1. So notice that has a unit of 1 in the x direction. That can describe my x's. Now, the other one is j, also written j hat, because it is a unit vector, and that starts here and goes up to 1 in my y direction. So we have two different vectors, I and j, and what this is going to do is allow us to make our component form of our vector look more mathy, I would say. Like it allows us to do some algebra with it without having to worry about the angle brackets. So let me show you this next line kind of runs through the logic using this. So assume we have a vector v1, v2. I can split this vector up. Make sure you agree with this. Anytime you have equalities, you need to make sure you agree with every equality before you go to the next one. So this makes sense because I can separate it addition-wise, because when I add it back, I just add v1 and 0, and I add 0 and v2, getting me back to where I was. The next thing they do, notice that this one, they take out v1. So this v1 would distribute, and that gets me back to that. Same thing with v2. And then all they did is they left the v1 where it was at, and they replaced this thing is equal to I, and this thing is equal to j. So they just replaced it. Let me erase all these lines. You need to make sure you understand this logic, where it's coming from. This is called a linear combination of, I thought I was grabbing my highlighter, a linear combination of I and j. Anytime I take two things and I put a constant in front of one and in front of both, and I add them together, it's called a linear combination of whatever we're talking about. So I'm going to write something here. This has nothing to do with our course. Don't write it down. But if I do z equals c1 x plus c2 y, this is a linear combination of x and y. Anytime I take a real number times a variable plus a real number times another variable, or an I and j, really times anything, you would call it a linear combination in that manner. Okay, so these are linear combinations, the IJ. You're going to use this quite a bit in my physics courses that I took. We used I and j. We never used component form. Just I and j. Calculus, we like component form quite a bit. I like component form purely because I'm lazy and it's less writing. And it's not very much less writing, but every bit counts, right? So let's do an example of this. Let u be the vector with initial point, terminal point. They want us, and v be that vector. Write each vector as a linear combination of I and j. Okay, so A is u. All right, so they gave me P and Q. You call them whatever you want. But u is going to be the difference between those two. So -1 minus 2. 3 minus -5. Be careful with that. So u is -3. That is going to be an 8. Almost got me. Right, this is the component form of that. If I want the linear combination form, I just do -3i with a hat, because it's a unit vector, 8j with a hat. We're done. That is the linear combination. It's a nice, easy change, but the whole point of this is a little easier to deal with in an algebraic sense, where we're going to be doing things in calculus and algebra with it. All right, B, we have W equals that, so I'm going to go ahead and first build all that before I like working in component form, and then I just switch it in the end. So U is -3/8 minus 3 times V, which they gave me. I'm going to go ahead and change it to component form, and I'm going to work this out now. Okay, so we distribute the 2. And distribute the -3. We can then add these together. I got a 0 and a 25. Okay, how we write this is I don't have to. I could write 0i if I want to, plus 25j, but we want simplicity, so we actually don't write the I. It's just understood if the I is not there, then it's a 0. So W is actually just 25j. All right, I got one more example. Just the setup's a little different. This was, I tried to accomplish a bunch of different things. They gave the vector to you. They gave you 2 points. You had to add them together and then change them. Try to give you an example of when I goes away, so that way you can deal with that. The last one we're going to deal with here is if they say a vector has a magnitude of 3, so they gave a magnitude and they gave me an angle. This is pretty common, right? If we're given a velocity, sometimes they say you're going this fast, and then there are bearings. I don't know if you guys remember a little bit about bearing. It's like describing direction based on north, south, and degrees. So they like to give directions in our real world with degrees rather than a component form or a vector. We're going to have vectors, but a lot of real applications deal with degrees. Okay, so I drew an XY plane to kind of save some video time, because I know if they're longer, you won't watch them. So here is my picture. If you need to pause it, please pause it, draw it. I have that vector at 30 degrees. And we're trying to describe, remember, I and J, I is just the change in X, and J is the change in Y. So we have old trig coming back to haunt us. We have a right triangle there. I'm going to go ahead and call this V1 and this V2. So can we make some kind of trig ratio using V1, 30 degrees, and the magnitude being 3? Yeah, we can. That is cosine. Cosine of 30 degrees is equal to V1 over 3. So if I solve for V1 here, V1 is equal to 3 cosine 30 degrees. I hope you know that 30 degrees. Cosine of 30 degrees is radical 3 over 2. There are calculators that will do that for you. You're allowed to use them. I think the TI 36X Pro is like $20 and it will do that for you. I like that calculator quite a bit. I preferably, for me, I would feel more confident using one of these rather than a like 83, 84. The reason being is those do radicals for me, and they also do trig ratios. Okay. Cool. Okay. I do want to specify, because I just confused myself. This is V1. It looked like a square root of 1 for a moment, and I was like, why is that there? Okay, so that's a V1. I can also use the same thing, but instead of using cosine for V2, I would use sine, right? Sine is always my y coordinates. That's V2 over 3. Solving for that, then we have V2 is equal to 3 sine 30 degrees. Sine of 30 degrees is 1/2, giving us a 3/2. So this means that vector V is V1, which is 3 radical 3 over 2, 3/2. But they didn't ask for component form. They asked for linear combination of I and J. So that's 3 rad 3 over 2, and then we put I hat plus 3 over 2j. Now, the reason being that we like this form is algebraically, the bottom one's going to be a bit easier to deal with. We'll see how that pans out. You'll have your preference. I know a lot of physicists prefer IJ and K when we get to 3. I like component form, pure laziness. Brackets are just easier to draw. I also think about my typing. A lot of typesets. You're gonna have to type a lot of reports going up. I'm gonna have you guys write your homework by hand. But if you had to type, this component form is much simpler typing in LaTeX or whatever math thing that you're going to type in. If you're interested in a language that will do that, this is the LaTeX. This is like the number one for math that people use. It's just a writing language. It's pretty easy to understand if you're into that kind of thing. I eventually started doing all my homework with that purely for the reason that I know if I did all my homework by pencil or pen on paper, I rarely would look back on it to understand it. But I know that once I started typing and investing a little more time in my homework, I know that's so annoying. But I ended up using it because it was typed up well. Also, my notes going forward, when I would finish this, let's say I was in Calc 3 and I typed them all up, I would have this nice pretty like document that was all Calc 3 that was typed up that I could go back and reference if I needed, and it looked nice and pretty. That's all up to you. I'm cool with handwritten, but I was wanting to explain why I prefer component form over linear combinations, and it purely is because it's easier to type. Okay, so that is vectors as a linear combination of I and j.